This is lesson 1.6, combining like terms. The objective of this lesson is that you can identify and combine like terms and write the expression in standard form. So first, what is a term? Let's recall. Numbers or variables that are separated by positive and negative signs. So here are some examples of an expression and an equation. And in this expression and equation, there are some terms in there. Let's see if we can identify. In the first example, 8 plus 2x. How many terms do you see? Remember that terms are separated by positive and negative signs. So there's 2. In the equation, we see 3 terms. The y minus 2x equals 8. Now the y in the 8, you don't see a positive sign, but we assume that it is positive if you do not see the positive sign. Same in the expression of the 8 plus 2x. We assume that that is a positive sign. So what are like terms? Like terms are terms with the same variable with the same exponents. Like terms can have, though, different coefficients. So go ahead and write that in your notes. And then we'll take a look at the differences between like terms and terms that are not alike. In the first example, you see 5 and negative 7. 5 and negative 7 are like terms because constants are always like terms. You might want to write this down. But then you see the x and y. X and y are not like terms because those are two different variables. In the next example, negative 3y and 4y, those are like terms because both terms contain the same variable of y. It's okay that their coefficients, the negative 3 and the 4, are different. And again, the example of negative r and s are not like terms because those are different variables. 5x squared and 2x squared are like terms. They have the same variables, and each one of the variables have the same exponent of positive 2. 4x squared and negative 2z are not like terms. Again, there's different variables, regardless of their exponents. And finally, 4a to the second b and negative a to the second b are like terms. They have the same variables. They both terms have an a and a b variable in it, and the exponent of 2 is both on the a variable. Look at the example of the unlike. A to the second b and b to the second a are not like terms, even though they have the same variables, and even though they have an exponent of 2, the exponent of 2 is not on the same variable. So the exponents must be on the same variable. So let's practice identifying some like terms. In each row there's 3 or 4 terms, and you have to circle the pair of like terms in each set. So let's look at row 5. You see an x to the second, and a negative 5x. Which one of these are like? Did you circle those two? Those are both like terms because they both have an x variable, and their exponent, even though you don't see it, is just 1, unlike the x to the second. Let's look at the next set. Y to the third, 3y, and 2y to the third. Your like terms are both the y to the third. Think of a term as like having a first and last name, and for you to be in the same family or being alike, you have to have the same last name, the variable with the exponent. The coefficients can be different, the first names can be different. Look at the last example in that row or set. You have a to the second b, 2a to the second b, and b to the second a. Go ahead and circle your like terms. And let's check to see if you got them right. Did you circle those two? The reason why b to the second a is not like to the other ones is because the exponent of 2 is on the b and not the a. Let's look at row 6. A to the second, negative 4a to the second, 2a, and 5a to the fourth. Circle your like terms. There they are, a to the second and negative 4a to the second. Remember that a term will have your variable with its coefficients and its sign, so you got to make sure you circle all of it together. Look at the next one. Negative 2x, 2xy to the second, negative 2x to the second y, and xy to the second. Look carefully and circle your like terms. Did you circle those two? If not, correct it. Those two are like terms. Yes, they have more than one variable, and that's okay. They both have an x and a y variable, and the exponent is on the y variable. Look at the next set. Negative 3x, 3x to the second, x to the third, and 4x to the third. Which ones did you circle? How about those two? They both have an x to the third variable. Alright, look at row 7. Let's see if you can do the whole row. All the way across to all three sets. In your first set, you should have circled the c to the second and the negative 5c to the second. In the next set, you should have circled negative rs to the second and 3rs to the second. And your last set, you should have circled negative 4x to the third y and the positive 2x to the third y. So why is it so important that we be able to identify our like terms? Because the key concept is like terms can be combined. When we say combined, I want you to immediately think of your SOB rule of integers. If the signs are the same, you add. If the signs are opposite, you subtract, but the bigger sign wins. So we can only combine, or use our SOB, like terms. Here in our example, we have 3x plus 2x to the second minus 5x. Just looking at that dark black there, can you identify the like terms? Let's see here. You should have circled those two right there, the 3x and the negative 5x. The answer is on the other side. That's why I didn't have you circle them. So, because those are like terms, we can combine them. Look at just their coefficients when you combine. When you combine, the variable is going to stay the same. So we have a positive 3 and a negative 5. Are those same signs or opposite signs? Well, a positive and a negative, so that would be opposite. So opposite signs you subtract. We always take our bigger number and subtract our smaller number. So 5 minus 3 is 2. But our bigger sign wins. 5 is bigger, so the negative wins. And that's how they came up with the negative 2x. The 2x to the second, you just copy down. You can't combine it with anything else. So when you combine your like terms, you are not evaluating the expression. Remember in our previous lesson, evaluate means that when you're done, you have one numeric answer. When you have an algebraic expression, all you can do is combine your like terms using that as SOB. When you're done, you may still have variables and more than one term answers. what we will do is write these answers in what's called standard form. We start off with our variable terms and then our with the highest exponents down to the lowest exponents, and then finally our constants. So let's take a look at these. Alright, let's take a look at some examples. Focus question number 1 says to simplify 5 plus 7a plus 7 minus 4a. First of all, let's make sure we understand what the word means to simplify. You're going to see this direction a lot. Before, remember, we had evaluate. Simplify means that you want to get the expression down so that there are no parentheses and no like terms. Now, the examples that you're going to have in this lesson, there are no parentheses. We don't have to worry about that. But the second thing of no like terms. How do we get an expression so there aren't any like terms? We're going to do this in 2 steps. First, you need to combine any like variable terms. We always start with your variable terms because we want to get this into standard form. Variable terms always come first. So I like to use training wheels of circles and squares, just a shape, so that I know, hey, I can combine my circles with my circles and my squares with my squares. So the first thing I do is identify all my variable terms. Look in the example again, 5 plus 7a plus 7 minus 4a. And I want you to circle the variable terms, the whole term, that's including its coefficient and its sign. You can circle those two? Okay. Because those two are like terms, we can combine them. We use that SOB rule. You have a positive 7 and a negative 4. Those are opposite signs, so you can subtract, or you have to subtract. 7 minus 4 is 3, and because the 7's bigger, the sign should be positive. The variable a just comes down with it. Alright. The second step is you need to combine your constants. We have 2 constants, the 5 and the 7. The 5 you don't see the sign, but we know that it's supposed to be positive if you don't see it. So you have a positive 5 and a positive 7. Those are the same signs, so we add them together. 5 plus 7 is 12. But notice, when you combine your constants in the expression, you must write the plus sign. The reason for this, the only time that you do not have to write the sign of a term is if it is what's called the leading term, or the very first term in the expression, like this 3a. We don't have to put the plus sign there for the 3a. But any term that comes after it, we must write the positive or the negative sign in between every term. So that's why you have to write the plus 12, or the plus sign in front of the 12, or positive 12. Alright, let's take a look at the next focus question. It says combine like terms. It could have said simplify, and it means the same thing. So our first step is we combine our variable terms. Look for your variable terms. Your variable terms were positive 9x and negative x. Now you must add their coefficients together using the SOB rule. Well, we have a positive 9 and a negative what? Remember, if you don't see the coefficient, it's 1, so it's a negative 1. You need to combine those two. Are those same signs or opposite signs? They're opposite because one's positive, one's negative, so you have to subtract. 9 minus 1 is 8, and the bigger sign is positive, so you write down 8x. We don't need to put the plus sign in front of the 8 because this is the first term in our expression. Now we need to look for our constants, the 6 and the positive 1. Those are both the same sign, so you have to add them together. 6 plus 1 is 7, and because it's the next term in the expression, we have to put the plus sign there. It's required. Now you will never, ever, ever have 2 signs in between. Like you would never write 8x minus positive 7. Okay, if you ever find yourself writing a positive and a negative side by side, you know you've done something wrong. Alright, our last example, and this is a little tricky. If our first step is always to combine our variable terms, you probably noticed already that there's a problem with this. We have lots of variables in this expression. So here's our rule. Normally we will combine our variable terms in what's called descending order. What that means is the highest exponent down to the lowest exponent. And then, if they all have the same exponents, we combine our terms in alphabetical order of their variables. So here's what I mean by that. So our variable terms, we're going to combine first our highest exponent. The highest exponent on all those variables is the x to the second term. So 12x to the second. But there's no other term that has the x to the second variable in it. So we have nothing to combine it with, we just have to write it down. Now if you look what we have left over, 6x minus 7y plus 12y minus 8x, we still have some like terms here, but which ones should we combine first? Well, which comes first in ABC order, the x's or the y's? Well, x comes before y in the alphabet, so that'll be the variable terms that we're going to combine next. So in ABC order, we'll combine the positive 6x and the negative 18x. Oops, I made a mistake there. Let me go ahead and fix that. There we go, that's better. So positive 6x and a negative 18x, those were opposite signs, so I had to subtract. 18 minus 6 is 12. Think about it. And the bigger sign wins. Well, 18 is bigger than 6 and it's negative, therefore it's a negative 12x. Then finally I'm going to combine my y terms. So I have the negative 7y and the positive 12y I need to combine. Those again are opposite signs, so I have to subtract. The bigger sign though is positive, so it's going to be a positive 5y. And that's it, you're done. You'll know that your expression is in standard form again if you have your highest exponents first, followed by terms in A, B, C order. So x term, then our y term. This is a 3-term expression. So again, remember the word simplify means to remove any parentheses and like terms, and your answer should be in standard form. All right. Good luck on your guided practice. If you need more help or more explanation, please see your instructor.